So the last thing we need to do for this week is simplifying trig expressions. So there's some guidelines we need to follow for simplifying trig expressions. The first thing we need to do is factor. So when we're factoring, we could use GCF, we could do difference of squares, perfect squares, kites. We could multiply with FOIL. Ooh, that's hard to read. Which is also the box. Or multiply by distributing. We can use the fundamental identities to change the way it looks and simplify it. If all above fails, we're going to turn everything to sines and cosines. This is my favorite method right here, to turn everything to sines and cosines. But when in doubt, try something. Don't just look at the problem and say, I can't. Try something. We have all of these fundamental identities down here. We can try something. Now, the fundamental identities are all listed here. And basically what they are just a list of things that rewrite the way things can look, okay? So tangent is, remember we talked about tangent being y over x? Well, tangent is y, which is sine over cosine. We're not going to write it in terms of y over x. We're going to write it in terms of sines and cosines. And cotangent was x over y, which is cosine over sine. And some people can't remember which one is which. Well, I always remember that c comes before t and x comes before y. So, oh goodness, cotangent starts with cosine. The reciprocal identities, they are basically just flip the identities over, okay? Flip these. These are flip identities. So tangent flips cotangent over, and cotangent flips tangent over. And these are the ones that people usually mess up. Cosine flips secant over, and sine flips cosecant over. So secant flips cosine over, and cosecant flips sine. A co will never flip a co. You'll notice that co does not flip cosecant, it flips secant. And cosecant does not flip cosine, okay? And cotangent does not flip another co. So all the co's flip something else. So that's how you know that those go together. Then the key ones here are the Pythagorean theorems. So we have sine squared plus cosine squared equals 1. Now, to get all these other ones, all I did was, for sine squared, I subtracted cosine squared from both sides. For cosine squared, I subtracted sine squared from both sides. Then here's my main Pythagorean identity for this. To get from here to here, I divided everything by, let's see, what did I divide it by? I divided everything by cosine. So if I divide this by cosine, I get sine divided by cosine is tangent, cosine divided by cosine is 1, and 1 divided by cosine is secant. And then I just rearranged it. And then I did the same thing down here. I solved for tangent, so I subtracted 1 from both sides. I solved for secant, so I solved for tangent, so I gosh, I can't talk today. So I solved for 1, so I subtracted tangent from both sides. So then here's the other one. And to get this, I divided everything by sine, excuse me. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared would be cotangent. 1 divided by sine squared would be cosecant. So everything is built off of this one trig identity, because I can get all the other 8 of these from this one thing by dividing or subtracting, okay? There are some basic factoring rules, but I gave you all the rules here, so you don't have to memorize these. So here's the difference of squares rule. So all I do is I take these rules up here and I say, okay, how can I rewrite this? Well, this is already in terms of sine. So I can say, well, this is sine of theta. And secant is, right here, 1 over cosine of theta. Well, what's sine of theta divided by cosine of theta? Well, that's tangent. So now I've simplified this into tangent of theta. Okay, so cosecant, again, is 1 over sine of x. Tangent is sine over cosine of x times cosine of x. Then I simplify that. So this is cancels with this cancels with this. Well, I don't have anything left. That's 1. Okay. This is secant, so I would say cosine of x. Secant is 1 over cosine of x minus cosine of x. Now if I distribute this, I get cosine times 1 over cosine is 1. And cosine times cosine is cosine squared. And I write it this way. So 1 minus cosine squared, well, according to my Pythagorean identities, that's right here, is sine squared. So secant is 1 over cosine divided by cosecant is 1 over sine. Anytime you have a fraction within a fraction, you flip and multiply. So flip and multiply. So this becomes sine theta over 1, and I multiply this. So this now is sine of theta divided by cosine of theta. Well, that's back to tangent theta. Well, 1 plus tangent squared, that's this, is secant squared. So if I do cosine squared times secant squared, well, now I'm going to turn this back into sines and cosines. Well, cosine squared is cosine squared. Secant is 1 over cosine squared. So cosine squared divided by cosine squared is 1. Well, sine squared plus cosine squared, that's 1 over cosine squared. Well, 1 over cosine is secant, and because it's squared, that makes squared. Cotangent is cosine over sine times sine. These cancel and leave me with cosine. Let's see. Tangent is sine squared over cosine squared times 1 over sine squared. That's 1 over cosine squared. So that's secant squared. So that's all we're doing.